So, let us move on to the next question, question number 21, integral 0 to 2 pi 1 upon 1 plus tan x power 4 dx. First option pi by 4, second option pi by 2, third option 3 pi by 4 and fourth option pi. So, what is that question number 21 here? Integral of 1 by 1 plus tan x power 4 0 to 2 pi. Now, we will use this property that whenever f of 2a minus x is equal to f of x, then integral 0 to 2a of f of x is equal to 2 times the integral of f of x dx from 0 to a. Use this property. So, now this is observe that tan of 2 pi minus x is same as tan x minus tan x, but then when it is raised to the power 4 there will not be any change. So, f of, if you call this as f of x, this will be f of 2 pi minus x is same as f of x. So, what we can do is we can write this integral in the form of 0 to 2 times of 0 to pi 0 to pi dx by 1 plus tan x power 4. Again we can revoke this, treat this as 2 times of pi by 2. Again tan of pi minus x is minus tan x raised to the power 4 will give me same thing. So, I can again write this as 2 times of 2 into 0 to pi by 2 of 1 upon 1 plus tan x power 4 dx. Now, again we use this property, use the property integral of f of x dx from 0 to a is equal to integral of f of a minus x dx from 0 to a. Use this property. So, now I can replace this x with pi by 2 minus x and write this as 4 times integral from 0 to pi by 2 of 1 by 1 plus cot power 4 x, because tan of pi by 2 minus x is cot x. Now, let us call this as some integral I. I is also equal to this. So, let us add this I and this I. So, what do we get? 2I is equal to 4 times of integral 0 to pi by 2 of, let us add this 1 by 1 plus tan power 4 x plus, I am adding the integrands because the limits are the same. What do we get here? This cot power 4 x we can write it in the form of 1 by tan power 4 x. So, taking the LCM and all that, we get tan power 4 x by 1 plus tan power 4 x dx. Now, as you can see, the denominators are one and the same in these two fractions. So, and then when you add up, what do we get? 1 dx. So, 4 into 1 dx 0 to pi by 2. So, that makes it 4 into pi by 2 and that is 2 pi. So, now 2I is 2 pi. So, cancelling this 2 here, what do we have? Therefore, I is equal to pi. The integral happens to be pi. So, option is, the right option is in fourth option. Now, let us move on to the next question, question number 22. The value of the integral 3 to 6 root x upon root of 9 minus x plus root x dx is equal to first option 3 by 2, second option 2, third option 1, fourth option 1 by 2. So, let us see how this goes. Integral 3 to 6 root x upon root over 9 minus x plus root x dx. Most of the definite integrals we must try to do them using the properties. Now, what is a fundamental property we have? The first and foremost property of this definite integrals is integral f of x dx from a to b is equal to integral of f of a plus b minus x dx from a to b. Now, let us treat this as a and this is b. This is our f of x. What is f of a plus b minus x? That is 6 plus 3 minus x. So, I have to replace x with 6 plus 3 minus x, that is 9 minus x. So, this integral, let us call this as I, can also be written as, I can be written as 3 to 6, replacing x with 3 plus 6 minus x, that is 9 minus x. So, what do we get? Root over 9 minus x here. 9 minus of 9 minus x and plus root 9 minus x. So, clearly that turns out to be root over 9 minus x by root x plus root over 9 minus x dx. So, if you add this I and this I, what do we get? The limits being same, we have 2I on the left hand side, on the right hand side 3 to 6, denominators being same, we can add up and what do we get? We get 1 dx, and that is, so 6 minus 3 and that is 3. So, 2I is 3, therefore, I is equal to 3 by 2, and that is seen in the option 1. So, answer is option 1. Let us move to the next question, question number 23. If the integral from 0 to infinity of x square dx by x square plus a square into x square plus b square into x square plus c square is equal to pi by 2 into a plus b into b plus c into c plus a, then the integral from 0 to infinity of dx by x square plus 4 into x square plus 9 is equal to, the first option is pi by 60, second option is pi by 20, third option is pi by 40 and fourth option is pi by 80. So, what we are given is integral of x square dx by x square plus a square into x square plus b square into x square plus c square is given to be pi by 2 into a plus b into b plus c into c plus a. If this is given, then we are asked to find out the integral x square by 4 I am going to write it as 2 square and x square plus 3 square. This is what we are asked to find out. Now, we are given a formula involving 3 symbols, 3 factors in the denominator, and we have only 2 here. So, what we do is we will introduce that factor, we will multiply and divide by x square, multiply and divide by x square, so that the numerator matches, denominator also more or less matches, because the first factor we can write it in the form of x square plus 0 square, x square plus 2 square and x square plus 3 square. So, it is clear that A is comparing with this equation, what is given? A is 0 and B is 1, sorry, B is 2 and C is 3. So, what do we get the answer to be? Pi by 2 into A plus B, that is 0 plus 2, B plus C 2 plus 3, C plus A, that is 3 plus 0. So, what do we have here? Pi by 60. Therefore, the answer is pi by 60. That is seen in the option 1. We have an alternative approach also. We can actually do it using the method of partial fractions. What is it? Dx by x square plus 4 plus x square into x square plus 9. 0 to infinity, alternative method, aliter. What I do is, I will subtract like this, split it into fractions like this. What do we get? We get 9 minus 4, that is equal to 5, but then you do not have a 5, so what do? We multiply and divide by 5. So, 1/5 of integral of x square 1 by x square plus 4, 1/5 of integral of 1 by x square plus 9 dx, 0 to infinity, 0 to infinity. Now, this is the standard integral 1 by x square plus a square. What is the integral of 1 by x square plus a square? 1 by a tan inverse of x by a. So, what do we have here? 1 by 2, 1 by 5 is anyway common, 1 by 2 into tan inverse of x by 2, x by a. So, a is 2 here, and then now again minus 1 by 3, because a is 3 here. So, tan inverse of x by 3, 0 to infinity. So, 1/5 of what do we have here? Pi by 4, because tan inverse of infinity is pi by 2. Pi by 2 into 1 by 2, that is pi by 4. Tan inverse of 0 is 0. So, lower limit would be 0. Pi by 4 minus what do we have here? Pi by 6. That amounts to, again, this is pi by 12 into 1 by 5, that is pi by 60. Therefore, we could have done this way as well without using this formula. So, in either case, we have the answer as pi by 60, and what is that? It is seen in the option 1. So, answer is in the option 1. So, let us move on to the next question, question number 24, integral 0 to 2 pi of e power x by 2 into sine of x by 2 plus pi by 4 dx is equal to first option 2 root 2, second option 0, third option 2 pi, and fourth option e power pi. So, let us write the question, e power of x by 2 into sine of pi by 4 plus x by 2 dx from 0 to 2 pi. What we do is we put x by 2 is appearing more than once. So, we will put x by 2 as some t. So, t will range from 0, 0 by 2 to pi by 2. So, pi e power t sine of pi by 4 plus t. What about this? X is equal to 2t here. So, dx will be 2 dt. So, I can write this as 2 dt. So, 2 I can write it outside, and I will write dt here. So, it is 2 times of integral from 0 to pi e power t. Let us expand this. Sine of pi by 4 plus t is root 2 times of sin t plus cos t. So, we can write that root 2 out into sin t plus cos t. Now, it is in some standard format now. This is f of t, let us say, this is f dash of t. So, it is in the form of e power t into f of t plus f dash of t. What is that integral equal to? We know that it is e power t into f of t. So, that is 2 root 2 into integral 0 to pi e power t into sin t dt. Sorry, after the integral it turns out to be this. So, the integral of e power t sin t plus cos t, that is, it is in the form of e power t into f of t plus f dash of t, that is e power t into f of t. So, we just have this, and it is clear that the upper limit and lower limit are both 0, because sin pi is 0 and sin 0 is also 0. So, what do we get? 2 root 2 into 0, and therefore, that is 0. That is clearly seen in the option 2. So, option 2 is the right answer. Yeah, let us move to the next question, question number 25. If in is equal to integral of tan x power n dx from 0 to pi by 4, then limit as n tends to infinity of n times of in plus 2 is equal to first option 1 by 2, second option 1, third option infinity, fourth option 0. So, we are given in to be equal to integral tan x raised to the power n dx from 0 to pi by 4. Then we are asked to find out limit as n tends to infinity of n times of in plus 2. Now, let us see what, let us look at what is in plus 2. What is in plus 2? Tan x raised to the power n plus 2. That we can write as tan x raised to the power n into tan square x. Tan square x we can write it in the form of secant square x minus 1 dx, 0 to pi by 4. So, we can now rewrite this as tan x raised to the power n into secant square x. I am splitting, taking it inside, taking it to 2 terms. tan x raised to the power n dx. Splitting the integral into two integrals now, 0 to pi by 4, 0 to pi by 4. Now, this is clearly in the form of f of x raised to the power n into f dash of x dx. So, what is that? That comes out to be tan x raised to the power n plus 1 by n plus 1. We use this formula f of x raised to the power n into f dash of x dx is f of x raised to the power n plus 1 by n plus 1 plus c, that is the indefinite integral. So, applying that, and this is in anyway. So, we can transpose this in this side, and we have in plus 2 is equal to, now what is it? When I apply the upper limit, we get 1 by n plus 1, lower limit n is anyway 0. So, 1 by n plus 1 minus 0, it is 1 by n plus 1. So, this in plus 2 part is turning out to be 1 by n plus 1. So, we can rewrite, therefore, the limit as n tends to infinity, n into in plus 2 will turn out to be n by n plus 1 limit as n tends to infinity, which is clearly 1. We know we divide both the numerator and denominator by 1 n. So, we get 1 by 1 plus 1 by n, limit as n tends to infinity. What about this? 1 by 1 plus 0, that is 1. Okay, so, finally, the answer is 1, and that is seen in the option 2. The answer is the option 2. Let us move to the question number 26. Integral 0 to pi by 2 of log of a plus b sin x divided by a plus b cos x dx. First option 0, second option pi by 4, third option pi by 2, fourth option log pi by 2. Let us see how it goes. Now, let us see if we can use some properties here. Integral 0 to pi by 2 is given. Now, I know that sin of pi by 2 minus x is equal to cos x, and cos of pi by 2 minus x will be sin x. So, if I replace x with pi by 2 minus x, there will be an interchange of the numerator and denominator in this logarithm part. So, maybe we can club them, and then we get log of 1. So, that makes it 0. Well, let us see how this is done. So, replace x with pi by 2 minus x using the property, there will not be a change in the integral. So, I is equal to this, and now when you do this, sin of pi by 2 minus x will become cos x. So, we get a plus b cos x, and then a plus b sin x. So, let us add up these two now. 2i will be equal to integral 0 to pi by 2. What is log x plus log y? Log of x into y. So, log of a plus b sin x by a plus b cos x, that is this, the first part, into the logarithm of this, I am sorry, into this expression, a plus b cos x divided by a plus b sin x. So, clearly there is cancellation here, we get log 1 dx, and that is 0. So, 0, finally the integral is 0, integrand is 0, the integral has to be 0. So, we have I to be 0, and that is seen in the option 1. So, answer is the option 1, option 1 is the right answer. Let us move to the next question, question number 27. Limit n tends to infinity 1 by n into secant square of pi by 4n plus secant square of 2 pi by 4n, so on so forth, secant square of n pi by 4n. First is equal to the first option 4 by pi, second option 2 by pi, third option 3 by pi, and fourth option 5 by pi. So, it is an application of integral as a limit of a sum. What do we know? Integral of f of x dx from 0 to 1 can be expressed in the form of limit n tends to infinity of sigma r ranging from 1 to n, 1 by n into f of r by n. This is the formula we are going to use this formula. So, let us see what we have is, we are given the limit, so we have to convert it into integral. So, limit n tends to infinity 1 by n, that is already given. Now, I will write the summation here, 1 by n into summation. What is it we observe? It is in the form of secant square of r pi by 4n, r pi by 4n, r ranging from 1 to n, limit n tends to infinity of this expression. So, this 1 by n is matching with this 1 by n here. So, this should have been f of r by n. So, wherever there is r by n, this r by n has to be replaced with x. So, what is your f of x? Secant square of pi x by 4, that is our function. So, comparing it to this, r by n has to be replaced with x. So, what do we have? F of x to be. So, therefore, f of x is this integral f of x dx from 0 to 1 is what you want. So, we have this integral f of x dx from 0 to 1 as 0 to 1 of secant square of pi x by 4 dx. What is the integral of secant square theta? Tan theta. So, what do we have here? Tan of pi x by 4, but then it is not simply secant square x. So, it is I will have to divide by pi by 4. So, that makes it 4 by pi, apply within the limit 0 to 1. So, what do we have? We get tan pi by 4 is upper limit, that is 1. So, 4 by pi into 1 minus 0, that makes it 4 by pi. Therefore, the answer is option 1. Let us move on to the next question, question number 28. Integral 0 to pi by 4 of sin theta plus cos theta by 9 plus 16 sin 2 theta d theta is equal to first option 1 by 20 log 2, second option 1 by 20 log 3, third option log 3 and fourth option log 2. Integral of sin theta plus cos theta by 9 plus 16 sin 2 theta d theta 0 to pi by 4. Now, if you observe the sin 2 theta, we can write it as sin theta minus cos theta the whole square, 1 minus of sin theta minus cos theta the whole square. Because what happens is when you open it up, you get a sin square theta cos square theta minus of sin 2 sin theta cos theta, that is, this becomes 1 minus of 1 minus sin 2 theta. So, that is sin 2 theta. So, the denominator can be expressed in the form of sin theta minus cos theta term. What about the numerator? Is that the derivative of sin theta minus cos theta? Yes, it is. So, what I do is I put sin theta minus cos theta as t. What happens when t is equal to 0? We get sin 0 0 and cos 0 1. So, 0 minus 1. So, we get a minus 1 here. T is minus 1 when x is equal to theta is 0. And what about here? We get 0 because sin pi by 4 and cos pi by 4 are both matching. We get a 0 there. What about this? If you differentiate, dt by d theta will be, dt will be equal to derivative of sin theta is cos theta plus sin theta d theta. So, the numerator is matching with dt. So, we have dt, t ranging from minus 1 to 0, dt upon, now this sin 2 theta we could replace it in as 1 minus of t square. So, that is 9 plus 16 into 1 minus t square. So, that makes it integral minus 1 to 0 dt upon 25 minus 16 t square. Now, this is in the form of 1 by a square minus x square type. What we do is we go for partial fractions. 1 by 25 minus 16 t square, we can write it in the form of 5 minus 4t and plus 5 plus 4t. When you add up, what do you get? This 40 will cancel in the numerator and we get a 10. So, we have to compensate by dividing by 10. So, 1 by 10th of 1 by 5 minus 40 plus this thing. Now, when you integrate this, when you integrate this, whatever, we will apply the limits later when you integrate this with respect to t. Now, we have this integral minus 1 to 0 of 1 by 25 minus 16 t square. I can split that as 1 by 5 minus 4t plus 1 by 5 plus 4t into 1 by 10. So, integral minus 1 to 0. What do we have here? 1/4 1 by 4th 1 by 10 into ln of 5 plus 4t divided by 5 minus 4t. Ln of 5 minus 4t within the limits now minus 1 to 0. So, now when we come to this 1 by 40 into what do we have? Log of 5 by 5, that is 1. So, log 1 minus log 1 by 9. So, what do we have here? 1 by 40 into log 1 is 0, and where do we have minus 2 log 3, minus of minus, and that makes it plus 2 log 3. So, that makes it 1 by 20 into log 3. So, the right option is option 2. Let us move to the question number 29, integral 0 to 2 pi of e power sine square n x into tan n x dx, where n is a natural number, is first option 2, second option 1, third option pi, fourth option 0. Now, integral 0 to 2 pi of e power sine square n x into tan of n x dx. Let us call this as I. I replace x with 2 pi minus x. So, what do we have here? Integral 0 to 2 pi, there will not be a change in this integral. So, e power sine square of 2 pi minus n x into tan of 2 pi minus n x dx. What we have is sine square of 2 pi minus n x will make it sine square of n x only. So, there will not be a change in that. So, e power sine square n x. And what about this? We get a minus of tan n x. So, that makes it minus I here. So, I is equal to minus I, therefore, 2i is 0. This implies I has to be 0. Therefore, the right option is answer is in the fourth option. Let us move to the next question, question number 30. Sigma n ranging from 1 to 10 of the integral minus of 2n plus 1 to minus 2n sin x raised to the power 27 dx plus integral plus summation n ranging from 1 to 10 of integral 2n to 2n plus 1 of sin x raised to the power 27. Options are 27 squares, second option minus 54, third option 54, and fourth option 0. So, 0 is one of the options. Let us see if these two can get cancelled. And you can see that by making a change of transformation here, I put in this integral, put x equal to minus t. What would happen? Minus t will become 2n plus 1 here and 2n here. What do we get here? Sin dx will be minus dt. And we have here sine of minus t raised to the power 27 minus dt. So, what does it turn out to be? Integral 2n plus 1 to 2n. Sin t raised to the power sine of minus t is minus sin t, that is raised to the odd power. So, that is going to give me a minus of minus will make it plus again. So, sin t raised to the power 27 dt. Now, the summation being the same, we can write it into one single summation, and then we have here, and we have 2n to 2n plus 1 sin x raised to the power 27 dx, but x or t, it is a dummy variable in this integral. So, I can rewrite x, put x as t there. So, sin t raised to the power 27 dt. So, and now these two are negatives of one another clearly. So, they cancel each other. So, each term in the summation will be 0. So, we get summation of zeros. So, the answer is 0. Therefore, option 4 is the right answer.